for those of you that are, I'm going to try and keep this mic close to my mouth as much as I can. For those of you who are virtual, because I don't have the ability to see who's putting their hand up, just interrupt me, just yell Clem, and I'll stop and I'll try to answer your question. So please don't be shy about doing that. Okay, so rather than going through the next set of slides again, and rather than doing that, let's go through a first few 4 or 5 questions in the lab. Okay, so the first question in the lab talks about what is the image, what is the hash of the disk image. Okay, any clues as to how you do that? That's one of the first things you do. Okay, I'm just, any ideas on how you do that? Anybody? I can give you 5 minutes if you guys want. Yeah. PowerShell. You can use PowerShell. Okay, so again, I'm going to try and handhold you through some of these examples, and so it's just take what you can out of it. Okay, if you really want the answers to exactly how I did everything, just send me an email, and I'm sure we're going to pass emails around later, and I'm happy to talk to you via email. Okay, but PowerShell, and I don't know if you guys can see this at all. You probably can't, but if you bring up PowerShell on Windows, if you go to the Windows menu, there should be an option that has PowerShell on it, right? So when you guys are in the, let me see. Does everybody know what I'm talking about? Okay, so if you go to the bottom left, right, and you click the little Windows, right, menu, there should be a Windows PowerShell over here. So just run the PowerShell, okay? And then you can see what I did here. All I did was, there's a command called get-file hash, right? I'm not going to go through all the options for it, right? Minus algorithm, and I wrote down SHA1. You can run different types of hash functions that you want to play with. And then the name of the file that you want to get the hash for. It's pretty simple. Okay? Hopefully you guys can do that. Okay, what's another option to do this? Many of the files where you guys downloaded the actual evidence file, where you uncompressed, where you extracted everything, there is right next to the image that you guys loaded, there's another one, there's another file called detect log 4shell E01. So if you click on that, there's a whole bunch of information that comes with the evidence file that was collected for you as you were analyzing the evidence for this particular system. Okay? And you're going to find a whole bunch of information here that is going to include names, sector count. There's a description here, right? There's an examiner, whoever put together this evidence file. And you can see in here that you're also going to find some of the other checksums, the hashes in here as well, some of those log files. Okay. I do not, let me see if I can make this any bigger. Anybody, I'm a Linux guy, so anybody know Windows? Control. Yeah, control plus sign. There we go. That's it. I was using a command. Okay, so you should be able to see some of the checksums in there as well. Okay, some of the hashes. So this just comes with the evidence file. It's part of the software. If you guys rather learn how to use the get hash file command, just use that in PowerShell. It's a little easier to do that, right? And it's good to get used to using the PowerShell. Okay. Okay. What was the next question? What is the computer host name? Okay. So for that, we need to go to the actual tool. Okay. And anybody, any ideas what is the computer's host name? We found that one out, or we can go through it pretty slow. Okay, I'll take you through it, right? So that you guys, because otherwise it's going to be impossible to. This is typically the homework that takes students approximately a week to do, and it's impossible to do this, right? In this setting. So I'm going to try and handhold you guys through this. So when we're looking at the the actual software, what you guys see in here, this giant screen, basically is that entire case that you guys have that loaded, that entire image, got converted into something that we can search things for, right? Which is really cool because in the past, these tools didn't exist. So you had to use something like 15 or 20 different tools to get the same amount of information that's collected for you here. Okay. Now, this case is made up of a single image. As I was telling some of you earlier, a typical case when you're investigating an organization is going to have maybe 10, 20 images from different computers. It's going to have 20 iPhones, a couple of smartphones. All of those images form part of one single case, right? And you can do that with that Axiom process. You can keep adding different images, and this tarball of information keeps getting bigger and bigger and bigger. But you can search it. And so what's really cool about this tool is that you can see on the left-hand side, you can see all the evidence, right? You can have a refined results, and you can see things like classified URLs, cloud services, Google searches, different identifiers for people. You can look at web-related things that appear in this image. You can also look at communication-related things, media, email, documents, all sorts of things that were captured from that disk, from that computer. So it's placed it in one location for you to make life a little bit easier. Okay? At the top here, you're also going to see a home icon. And then here you see artifacts. You can have a case dashboard. So if you go to the case dashboard over here, it takes a couple of seconds to go to the case dashboard. The case dashboard gives you a whole bunch of information about the case, right? All the artifacts that we found 65,000 artifacts, the operating system, there are 51,000 artifacts in the operating system, web-related, custom, all sorts of things that this software captured for you. You can already see some really interesting potential investigative areas in here where you could look at these types of files for these tools and use some kind of AI technique to look for patterns that are really interesting, right? So there's already potential for doing things here that are more academic, right? Rather than doing things manually like we're doing here. But in here, one of the things that you can do, you can look at the second column that says case overview. And again, stop me for those of you who are virtual who can't see this. But the second column from the left says case overview. And if you go all the way to the bottom, there's a little section or a widget that says case information. The first link under that says open case information file. So if you click on open case information file, okay, you're going to see in there a lot of information about the computer where this is being done. And so here, you're going to have a host name associated with that. Right? Let me make this bigger. Okay, can you guys see that? As you guys are working on this, perfect. I got a thumbs up from that, right? So hopefully everybody has a different host name, right? Good. All right. So this is an example where, okay, what was the computer that's likely the target of this, right? So there's one of your targets, right? This is that computer name. There's also other information in here that you can play around with, and right? There's a build, right, in here, 6103. I wonder what that is, right? We're going to find out at some point. Okay, so let me close that. And I'm going to go back to my artifacts in here. By the way, if any of you try to click on the registry, don't do it for now. I tried clicking on the registry, and in AWS Workspace, the registry seems to take forever. So unless you want to be rebooting your workspace, don't click on the registry search. This is just one of the nuances of doing AWS Workspace for now, but we're not going to need it for what we're doing here. Okay, so that's okay. All right, so the next question that we had in the lab said, what is the computer host name of the compromised system you're analyzing, the target? Okay. So one of the things that I can do is I can go to the artifacts. So go up here on the top left-hand side next to the little house, and click on artifacts. And sometimes it takes a couple of seconds to load all the information. Okay. You can go to look at refine results. Okay. Then go to identifiers device. It has a 47 artifacts next to it. So we'll click on that. It takes a couple of seconds to load. And you're going to see a whole bunch of evidence here, all the files. And you can see on the far right-hand side, there's additional information on the selected item in the middle column. So you have a little bit of additional information that you're going to find on that selected item that pops up on that side. Okay. Again, you don't have to know everything here. I'm just giving you a tour of how you find some of this information. So if I'm looking for the computer host name of the compromised system, I'm probably going to look for something that says computer name or something like that. And so in here, one of the things that I can do, if you click on the column, you can alphabetize what's in the column, right? In this case, we don't have that many, so I can just scroll down a little bit and see if I find something that says computer name. And guess what? It's right there. There's something that says computer name, right? You're going to find it somewhere down the middle of that list. And guess what? You have a computer name right there. It's called BCW65. Everybody good with that? Everybody found it? In fact, there's another one right above it that says display the computer name. And it also has a little letters BCW65. Okay. So now we have an idea. Okay. So now we know what is the computer host name of the compromised system. Okay. All right. Good. Has everybody been able to do this so far? Okay. All right. Good. I'm getting thumbs up from people, so that's good. All right. So then, so you, when you look at the information on the right-hand side, let's see if we can find anything that's a little bit more interesting. I'm not seeing anything more interesting in there. Look at the display computer name. No, I'm not looking at anything that interesting in that side. That's going to give me more information. Okay, what is the time zone of the compromised system? So the time zone is just not stored in the refined results. Okay, so we're going to click on the refined results little arrow. I'm going to close that one. Okay, and typically the time zone, and again, this is as you get savvy using a tool, you're just going to know where to find this information. I will never expect you to know in which of these tabs you're going to find some of this information. You just get to know this over time, right? And you're going to have a cheat sheet as you're working through different cases on how to do this. So the time zone is going to be stored typically under operating system, right? So if you click down the operating system tab, let's see if we can find a time zone in the operating system here somewhere. Yep, guess what? If you go, this is alphabetical, so if you click on time zone, right, you only have a single entry in here, right? And that single entry tells you that this is Pacific Standard Time. Okay, so that's the time zone of the computer that appears to be compromised. That's how all these things were logged in that system. Again, we're not doing anything academic here. All we're doing is you're just being a computer operator who really knows how to use this software and they know what to look for, right? That's all you're doing, right? Now, as a computer scientist, I'd probably say, can we just automate this? I'm just going to write a program that reads one of these files and I'm going to print all this information for you. Of course you can. And this is what some of the smart guys are doing, but it's good to have all this information available like this. Okay. All right. So we have the time zone. All right. If you look at this whole operating system area, there's a whole bunch of really interesting information about the operating system itself. And so the next question that we asked was, what is the current build number of the system? What is the operating system version? So guess what? I'm going to go to operating system, and I'm going to look for that operating system version somewhere. So this operating system information here, I wonder if that's got something interesting there. Guess what? There it is. Right? This is a Windows Server 2016 standard evaluation version 6.3. And if you look in here further, by clicking on that, the artifact information reveals a lot more things in here. Reveals the DNS server, IP address, reveals the computer name. Let's see if there's anything else that's revealed in here. That appears to be it. Right, so we have a whole bunch of information by looking at the operating system. All right, next question. What is the computer IP? Okay, let's look at the computer IP. So for that, we're going to go to the top here. Okay, so we're in the operating systems. So let's look for see something that looks interesting. I would say network interfaces. Again, under operating systems, right? So if we click on network interfaces, okay, there you go. Ethernet 0. Okay, this is your local IP. This is the IP of the system. So 192.168.112.139. Okay, that's your IP address. It's listed right there. Now, I don't want to get into how IP addresses work. We're going to talk a little bit about it before the network section of the lab. There's a million different YouTube videos, snippets, 5 minutes, that show you exactly how IPv4 and IPv6 work. So you guys can take a look at those if you want. Okay, but here you can find information about, again, under operating system, you're finding a lot of information that's relevant to the case and to the lab that we're doing. Okay? The Ethernet 0, it's basically a virtual network interface that is used for VDSL configurations. This is very high bit rate interface. But this is where you find it. Okay, so we've seen that many of the operating system have information is found here. You're also going to see one of the areas that we're going to go into it a little bit later. There's something called a shim cache, and there's going to be something else called an AM cache that we saw on one of the slides. We're going to go for search for some of that malware. So we haven't looked for any of the malware yet, right? What we're doing is finding out a little bit of descriptive information about the system, the time zone, its IP address, all of these things. But we haven't looked for any evidence of malware in the system yet, right? The task in the lab says, hey, this company was attacked by a Log4j, malware. We need to go find evidence of that. Okay, so far, what we're doing is just, looking at a description of what we have in front of us. Okay, so that's all we have right now. That's all that we can do. Okay, let's look at what's the domain that the computer was joined to. So. What is the domain name? Anybody find the domain name of VCW65? Anybody find that domain name? Anybody look at that, or how do you find that? Cyber Defender Role. Under the network profiles tab, and right under network interfaces, right? You found the Cyber Defenders Role domain name. Okay, so that's really cool. So now we're able to find that as well. Okay, network profiles. Okay. There it is. Okay, cyberdefenders.org. Okay. Right, a lot of information is popping up. So we're learning quite a bit about the system. All right, so now There's also another place you can actually look, and I wrote this down because I wanted to share with you. A lot of Windows systems store IP information on a file called tcp/ip.sys. So you can look at that, and this captures that as well. So you can go to, let me see if I wrote it down. I don't use this tool every day, by the way, so it's not my job. Okay, so if you go to artifacts, operating system, system services over here. Let's go to 516 artifacts. Okay, so this is a much larger set of results that we have here. So I'm going to sort them. So if I click on the column, the top, just the name of the column, hopefully it sorts them without hanging my head up. There you go. And so I'm going to look for TCP/IP. Let's see. Find it. It should be a tcp/ip.sys file. There it is, right at the bottom. I found it. Right. So if you look at that file, there's a whole bunch of information here. Okay. So let's look at the contents. And there should be, let's see if we can find the cyberdefenders.org. There's the second one. Good. Oh, thank you. So let's look at that one. Let's see if I find it in there. Otherwise, you would have to open the file. No, I'm not seeing it. Oh, there it is. Right here. There's the domain. So under hosted services parameters, you're going to find the domain name, and there's cyberdefenders.org. So you can see that this is not, you almost have to know these tools really well to know exactly where to look. However, you'd be surprised how quickly and how good you get at doing this. Okay, because you're going to have your list of things that you check for, and you're going to go look for these things fairly quickly. What's also really cool about tools like this is that it has an unintended effect of teaching people what's in your computer. Okay, a lot of us don't know what we carry on our own computers, and so this really teaches you a lot about what's inside, what's kept on your system, on your disk. Okay, so it's a really, really cool tool to use for that. Okay, so so we looked at a lot of descriptive data. Okay, now we want to start looking at something else, something beyond just the description of the system. And so I'm looking now at, I think it's in the lab, it's letter H. I think letter H says what non-built-in applications are installed on this system. Okay, so what's running on this system? So what I'm going to do, okay, you can go to artifacts in here, and you can go to application instead of the operating system. Go to application usage. So click on that, right? And you only have 3 different options. One says install Microsoft programs. So what's Microsoft running on this machine? So if you click on that, a couple seconds, you have a whole bunch of Visual C++ Studio running on this, right? Okay, well that's not interesting because we want to see what's a non-Microsoft installed program. So if I click on install programs, not the Microsoft ones, now we're getting to see a little bit more interesting information. And guess what? One of the things that we were looking at is the log4j, and what is log4j attacking in the system? If you know a little bit about log4j, and if you're working in the cyber malware, detection kind of world, you're going to know that log4j is known to attack the VMware systems. Okay, you would just know that. Okay, trust me, right? Because that's what you're working on. So what you're seeing here is that, oh, okay, this person has Mozilla Firefox installed, they have Notepad, and they have, look at how much VMware stuff is installed in the system. So, okay, now we're getting somewhere, right? We're looking at investigating this log4j malware running on the system, and we know that there's a whole bunch of VMware running here. What is the one that I really care about when I start looking at all of this? The one that you really care about, the one system that controls all the virtual machines that are in the VMware environment is going to be that vSphere that we saw on that previous slide, or that it goes by the other name of vCenter Server. Okay, so VMware vCenter Server or VMware or vSphere are two names for that control daemon. If you know what a daemon is in Unix, right? The program that's always running to do something. That's the one program that's really attacked by that log4j. So you would also know that, right? And so now what you can do is take a look at that and say, okay, well, is there any additional information for the vServer? Okay. And we're going to play a little bit more with that. So there's a DNS server. Where's the center? Okay, server. And there's additional information in here. It gives you the version, right? VMware, all sorts of things. You can also, by the way, Google is one of your greatest allies when you're doing forensics, because whenever you don't know something, you're going to find information in Google. So if you look for, vCenter server, it'll tell you that it's also known as vSphere. If you don't know, you can actually Google what is the most common software that's attacked by log4j, and it'll tell you. And so don't ever be shy about using some of these search engines to look for clues that are going to help you search this nice big tarball more efficiently. Okay, so we've done that. Okay. All right, so go to the next part. It says, what applications are internet facing? Okay, so we're going to go to the artifacts again. Okay, so we're in the artifacts. Okay. Interface facing mean what are the things that that they're actually connected to the internet in one way or another. So Notepad is not going to be one of those, right? But if you're in the installed programs, you know that Mozilla is going to be something that's interface facing. You know that vServer, okay, platform services. You know that vCenter Server is also going to be something that's interface facing. Okay, so these are some of the things that are being connected to the internet, and so these are likely to have been the ones that are infected by malware. Okay, and so you've done that. Okay, we go to J. What are the versions of these applications? What are the versions of the applications that are present on the system? Okay, so you can just click on that vCenter and it should tell you in here, and you can find out on the right-hand side column that it's version 6.7.0.40322. So just having this information alone, you can actually start Googling blog sites and say, is VMware the server affected by log4j? And guess what? You're going to start getting a whole bunch of additional information. So those are things that will go into your spreadsheet of doing. What are the things that you're doing to find out some of this information? And then if you find something in Google that helps you with that, then you go look for it in here. Is it in the evidence file? You find evidence for it in the actual machine manufacturer, right? Okay. All right. So in K, this is where we start looking at more vulnerabilities, right? Are there any recent vulnerabilities that impacted these application versions? So if you just even type that question in Google, it should come back with log4j as being one of those malware that affected vCenter. Okay, so you would find that information out. And so the answer to that question, right, should be that you will find some of these weaknesses affecting vCenter or VMware. And in many cases, you're also going to find out the exact CVE or the CWE ID. Does anybody know what CVE and CW? Do you guys know what CVE and CWEs are? Okay.
Common vulnerability enumeration.
Common vulnerability exposures and common weakness enumerations. Exactly. I made this a mistake. Don't worry about it. I was corrected too. All right. If you go to a website called mitre.org, mitre.org, they have the full database organized in such a way that you can look at all the CVEs and all the CWEs from different perspectives. As a developer, as an administrator, right? And you look at them, and some of the CVEs or CWEs are families of things, and so you can, they're kind of hierarchically organized, and so you can look through those. What's really neat is that by having a common numbering system, you can all refer to these vulnerabilities or enumerations by that single ID, and you're going to find things like, what are the consequences? What are the examples of things that can cause this? And so this continues to grow all the time, okay? And so you would do that just by Googling. You're going to find a lot of that information that here's some of the CVEs or CWEs that affect vCenter, okay? And you're going to find out in the next exercise, L, what software was exploited to compromise the system, and you're going to find out that vCenter Server and VMware Apache Tomcat are two of those systems that are affected by Log4j. And guess what? We have both of those things in here. We have Apache, and we also have vServer installed in this particular image. So we have evidence of the software being installed in the image. We found on the internet that there are certain CVEs associated with Log4j, and it appears that this system is somehow associated with that. So that's really cool. We're getting somewhere now in terms of figuring out, okay, what's the malware? Is this the only malware that's in the machine, right? Is it just the Log4j? Could there be other stuff in here that's also affecting the machine? And so we're going to look at those things as well, okay? So let's look at M. M says, where are inbound HTTP requests to the system log? Okay, one of the things that you can do, now we're starting to get into a little bit more real digital forensics. Okay, you need to know something about where does, if you are the administrator for VMware on your organization, you're going to know that vCenter is the principal control system that dishes out all the different virtual machines and whatnot. You're going to be intimately familiar with that software, and you're going to know where the log files for that software are. So maybe one of the things that we want to do is go and look at the log files for that vCenter to see if some of that malware, is doing anything to that particular server. So what we're going to do, okay, we're going to go to in the artifacts up here on that menu. We're going to go to File System. So just click on File System. And now you have a different view, right, of all the information that we captured for this machine. On the left-hand side, one of the things that we can do, we're going to expand the file system, right? Let's just expand the file system. This is what was in that machine, right? This is the file system that was captured for this image. Okay. So one of the things that we're going to do, and again, you would know this if you're a VMware administrator, you'd know that under program data in this machine, you're going to have a whole bunch of log files. Okay, so you go in here, and I'm going to look for VMware right here, right? So I find VMware in the operating system, and the program data, VMware. There's a couple of places where I'm going to look in here. There's a logs directory in here. Okay, well, there's nothing there. Okay, so I hit a dead end on that particular logs, but I can also go in here and go to the vCenter server. Let's see if this specific daemon has additional logs. Okay, vCenter, there's a runtime, so we're going to go into runtime. I go to runtime. This is the actual daemon name called STT service. And in here, I'm going to find a whole bunch of logs. Again, here we are. So we have a whole bunch of logs. I don't expect you, unless you're an administrator, to know exactly where the log files for this sphere are. Okay, you wouldn't know that. Okay, but with a little bit of Googling, you'd probably be able to find out where all the runtime log files stored. Okay, so all we did was traverse program data, VMware, vCenter server, runtime, the name of the daemon that actually runs where SP as service, and then logs. And I find a whole bunch of logs here. Some of them don't have anything on it, they're size 0, but some of them have quite a bit of information. The first place I'm going to look is audit events.log. That's a really cool one. And so what I'm going to do, okay, so you can look at audit events.log first. You can right-click on the log file and you can open it with maybe WordPad. Let me see, yep, open it with WordPad. Click OK. And now I'm looking at an actual log file. Make it a little bit bigger. Now it's not working. Anyway. All right. You have a log file in here. Now you can start looking at a lot of interesting things. Okay. A lot of these entries, okay, are multiple lines. So here's a multiple line entry, for example. And you start seeing different users that are trying to access this machine, right? So here's a user, Mustafa Husseini at BCW65. And you can start looking at what they're trying to do, right? You start searching for different things in here. Here you have something that says login success. So you can start monitoring and taking a look at this and finding out who's successfully logged onto the machine, who hasn't logged on. You don't have to know the exact format of how these tools are logging information. You just have to search for certain strings that you may be savvy about. Hey, log4j is doing this thing or is doing this thing, right? And so then you can search for those strings and take a look at this. And so I'm going to search for, let me see. Not that. Okay, I'm going to search for something called Huntress. Okay, I just know I searched for, if you guys look in there and I have it highlighted, I searched for something called huntress.com. So if you go in here, you're going to see log4shell.huntress.com as one of the entries in that file. The file is not that big, right? But this entry in particular that I'm highlighting, the third line, you're going to see at the end of the third line, that this will be virtual, but there's something there that says log4shell.huntress.com. When you're playing with log4j, if you were doing a lot of work on log4j, you're going to find out that this huntress.com, it's actually a public tool that is used to test servers to see if they have the log4j vulnerability. And so I would know, right? I'm somebody that's trying to infect a machine. I know that huntress.com is a tool service that allows me to probe those systems to see if they're vulnerable or not. So by searching the log file to see if anyone is doing something from this particular domain, that tells me, hey, guess what? Somebody's doing something here, right? And so I have evidence now that some user, right, at a certain date, at a certain time, it appears that this is December of 2021, sometime around the 29th of December of 2021. Somebody was making calls from huntress.com to see if they find the vulnerability for log4j in this particular machine. Okay? You see how difficult to do digital forensics is. Okay, this is not simple, and I tell people this is not just the CSI show where you see the fun part, everybody going together in a room that looks half blue and with blue lights everywhere. Everybody's drawing dots next to each other. True digital forensics is going through a lot of evidence like this and log files to see if you find stuff, right? And so you see that this is already open for a lot of research questions, right? As I was mentioning earlier, you can do a lot of detection and a lot of tools that can just parse these things for node type strings. But here's one example, right? So we found this, okay? So let's see if we can move on to the next part. So what tool did the attacker use to exploit the system? Okay. So by looking at the logs, okay, the first thing I'm going to look at, let's see if there's, in this particular entry, right, I'm going to highlight this Huntress, right, the entry in the log file for that person using the Huntress tool. That entry has an IP address, and that IP address is the IP address very likely of the person who's trying to get into this particular system. And so this is the attacker's IP, 192.168.112.128. And it says here that it failed to log in, right? It failed to log in. So if we search for that IP address in the log file, you might find a lot of these entries with login failures, meaning there are multiple attempts to try and get into this particular system, right? So that's really cool. Now you're finding out that this particular IP address, right, is trying to actually, right, log into this particular system, okay, number of times, okay? All right. So let's look at the last entry in this particular log file. So let's look at the very last entry. Okay. If you look at the very last entry on this particular file, okay, you're going to find another tool in here. There's a tool here called, I'm going to highlight it. burpcollaborator.net. You go on Google burpcollaborator.net, or you start playing with burpcollaborator.net, you're also going to discover that this is a tool that helps you look for vulnerabilities in the system. So all the tools to be a bad person are out there. It's just a matter of you wanting to be a bad person. Okay, but if you're going to be a bad person, make sure you know how to cover your tracks, because we know it's a game. We know who's doing what and how they're doing, right? So unless you're an expert in knowing how to cover your tracks, don't try to do this in a nefarious way, because you will get caught. Okay. By the way, the number one, if you want to be a target for somebody monitoring you, download Tor. Okay, that's the first thing people are going to look like. DHS is one of the first things they look at. They know who's downloading Tor. Okay, so anyway, so we have Burp Collaborator over here, all right? And so here's a tool that helps discover lots of kinds of vulnerabilities. So we have another example there. Okay, is there evidence? So if we move on to the next thing, it says, is there evidence of application security scanning to determine if the system was exploitable? Okay, if so, when did this activity start? And so what you do in here, one of the first things that you do is you can just look at this this very same log file. There's other log files. I'm not going to go through every log file in this particular lab because it takes forever, right? You're going to find that all these login failures started very early, right? And most of these entries in the log file had a timestamp. So you can start looking at that timestamp and you can start putting together that timeline. Remember, we talked about the timeline and how important that is. And you're going to see that there's a timeline when people started scanning this particular system. Okay, so we started doing that at that particular point. Okay, when was the first successful logging? Okay, one of the things that you can do is search again the log files. If it's a web call, what is the return value for a successful web call? So what's a 404? Then you guys get a 404 all the time, right? What's a 404?
400 code is a client error, 200 code is a success.
And 200 is a success. So what would we look for in here? We would look for a 200 to see if there's any successful calls that are made. So again, that comes from just knowing that, hey, somebody's pinging the system on the internet. Are there any 200 log calls from this particular user? And so we start digging into that as well. Okay. We already found out what the attacker's IP address is. Okay, that was the next part in the lab. That was R. Right? Now, the next one. How did the attacker attempt to gain persistence on the system? Okay. How did they attempt to gain persistence? So, you know already?
Is it the backdoor.exe was 5A?
There's one example. Was that successful? Okay, that's the next question. But okay, so there's one example. We're going to look at this was part of the slide, but I'm just going to go ahead and do it here since I got your attention. I think this is interesting. So one of the things so if you look at what you were talking about, let's go to, let me close this. Yeah, don't save. Okay, so we're going to go back over here. We're going to go back to artifacts. Okay. We're going to go to the operating system. And there's one place that's called, let's see, down in here. There's something called auto run items. Okay. If I know that you don't know a lot about your own Windows system, I'm going to try and install something on your system. And guess what I found there, right? Look at that. Backdoor.exe. Okay, so it looks like somebody was trying to install something on the system, right? Now, was it successful or not? One of the things that we can do is that if they try and put that in the user's administrator desktop, right? That's the file path. So you can look in there. So we can go, let's see, we can go up here. We can go to the file system to look for users administrator desktop. File system. Okay. Let's see where the users are. Users down here at the bottom, administrator. Let's go to the desktop. Is there a desktop in here? Desktop. No, that backdoor entry is not there. So they were not successful using that. That was one example. That's one malware. Okay, that's different than the log4j. Maybe not, but who knows what they were trying to do. But they were not successful with that attempt. Okay, because they didn't leave behind a backdoor entry that executable. Now, that's one of the first places you guys should always monitor in your machines too. Wherever you have auto runs, if you have a Windows machine, make sure that there's nothing in there that looks like backdoor, right? It's probably not going to be called that. If they're a savvy attacker, they're going to call it something a little bit smarter than that. Windows 32 essential.dll or something like that. I think like, well, I'm not going to do that, right? So here's an example of one that didn't work. Okay. The other thing that we can look at, okay, we're going to look at, let's go back to the artifacts. Is this working out okay for you guys, or is it? I mean, I think if I leave you guys trying to do this, it's not going to work because it takes that long to get used to learning and all of these things. And so I think this is better to guide you guys a little bit. It's more prescribed, but hopefully it works a little bit better. Okay. All right. So we're in the operating system. Let's look at, this is another place where if you're an investigator in forensics, one of the first places where you look at is the PowerShell history, right? What commands are people trying to execute on my machine? Okay, so you're gonna go to the operating system and click on the PowerShell history. Okay, so I'm gonna click on that. It looks like there's 11 things in there. Okay, everybody found that? Okay, look at the last entry in there. Oh, this looks interesting. Whenever you see a whole bunch of garbage like that, it gets my attention really quickly, right? But if you look at the last entry here, the PowerShell here is doing an operation with an option that says hidden and then encoded command. So they're trying to hide what they're doing, right? And if you on the far right pane, get additional information on what this is, right? All of this is the encoded command. So this is, what's the encoding being used here? Anybody have any clue what encoding is being used here? Base 64, right? That would be one of the first guesses that you look at. There's lots of different ways in which you can encode things, but I can look in here, right? And I can go down, I'm gonna view more, and I'm gonna see the entire command, right? That's there, right? All the way to the end. By the way, if you want a hint, if you see a couple of equal signs at the end of any one of these encodings, that's typically a sign that this is a base 64 encoding. A lot of email uses base 64 encoding, right? You can see zip files and things like that that say that they're attached as base 64 encoded files. Okay, and you're going to see a lot of that stuff. But that tells me that this is, some command that is somebody's trying to run on my machine. What do I do now? Where do I go with this? Okay, there happens to be a really cool tool on the internet. Again, you're learning more stuff, right? I'm going to go because I have it set up here. There's a really cool tool available to everyone that happens to be called CySER Chef. So if you go to cyderchef.com, think of cyderchef.com as your Swiss Army knife for data. Anything that you need to do, manipulate with data, we use cyderchef.com. Okay? Do this on your own. You can bring up, do it separate if you want to. I don't want one thing before you guys do anything here. When I try to cut and paste this string that I got from the forensics, and I try to paste it inside CySER, inside AWS Workspace ends. So don't do it. Just trust me, and I'll show you here on the screen. Don't mess with your AWS Workspace. You're gonna have to restart it, okay? So, and again, I don't know why. That's just the workspace environment in AWS, and I don't get why it doesn't work that way. So what I did is I just copied that entire string that I found on that file in the digital forensics file that I had, right, in PowerShell. That was an encoded command, and I pasted it on the input window that you guys will see. Okay, so the output that you get is whatever recipe you want to put together. Okay, so I'm going to throw away the recipes that I have here right now. Go back. Sorry. Okay, we're going to null that out. So if I don't have any recipes, the output is going to be identical to the input, which is on the top. Okay, you have the top and the output are identical. Over here on the left-hand side, you have all sorts of different algorithms that allow you to play with data. Really common algorithms that are out there. So the first thing, because I know that there's an equal sign at the end of the input string, I got the hint that this is a base 64 encoded string. So I'm going to look here for the base 64. So I'm going to look for favorites because this is one of my favorites. So I'm going to grab the base 64, and you can put it over here. You just drag and drop, but I already have it here, so I'm going to turn it on. Okay, so when you turn it on, the output looks like this. Okay, this is not telling me a lot more over here, right? Not saying a lot. But when I look at a lot of this stuff, when you have lots of dots in between, I also think that there's probably a lot of null bytes in there. So again, this comes with time. As you're looking at data, you'll be surprised how good you get at reading really obfuscated information and getting good at trying to decipher what it is. So I'm gonna look, search for null. So here's a remove null bytes, and I'm gonna drop it here. Okay, now I've removed all the null bytes. Notice how this is being done from the top to the bottom. So I'm running this recipe by running these algorithms one after the other. I have it on auto bake, right? If you don't have it on auto bake, you have to bake it every time you're playing with that code, right? To run the algorithms again. So this is really cool. Now I have some additional information here. When I look at, yep. So
It's very obvious that this is UTF-16.
okay, maybe to you, right? But not to everybody. Okay.
Supposing that there are bytes other than null bytes in there,
Mhm.
that, like you wanted to straight say, okay, take this from UTF-16 and turn it to UTF-8 or UTF-8
Yep.
Does that option exist on?
You can do just about anything you want with CyberChef. Yep. You can do all sorts of things with it. The hard part about CyberChef is knowing what order and what algorithms you want to run. That's just the hard part because the tool is there for you. You just have to get good at kind of deciphering things and looking for certain things. Okay. In this case, so we run the remove. We did it from base 64 and we removed null bytes. And I have something here that I think I can comprehend, right? And so what I see here is that there's something else in here that says from base 64 string. So what I'm going to do is I'm just going to copy this string that's here and put it on the input again, right? So one of the things that you can do is you can say over here, you can say replace the input with the output. So I'm going to do that. But I need to remove all this garbage here because that's not really part of the string. So I'm going to remove that. There's probably something at the end. So I get to here, I'm going to remove this. That's where the string ends right there. So I'm going to press delete that. And now I have a whole bunch of additional information that's here, right? That, again, looks like gibberish. And so I'm just going to say, this is still from base 64. I know it's base 64. I'm not going to remove the null bytes, or I'm going to keep the null bytes in there. It doesn't look like this is a null byte thing. It just so happens that one of the things that you should always try as well is.
I noticed there was something interesting at the end of that string.
Okay.
It's actually gzip inference.
Oh, where did you see that?
So if you do undo on the input there, you'll see it.
This one?
So like on the top of your input, you know how you were removing the
Yeah.
you were removing the matched end parentheses.
Okay.
Right. There was also a string that had something to do with decompress.
So you notice that something that says gun zip or something like that. Okay. So what are we going to do here? Okay. I'm going to leave that here. I'm going to keep the from base 64. I'm going to search for gun zip. There's gun zip over here. So I'm going to put this here. Gun zip. Okay, cool. Look at this. We're getting a whole bunch of stuff that's readable. And now I'm seeing, whoops, another from base 64 string over here. Let's follow the crumbs, right? So let's copy this and put this output and put it on the input. And now I'm going to see if I can just look at that particular string. So I'm going to remove this. Right. Remove that, and let's see, is there anything at the end? Yep. So, okay, so I'm going to remove all of this. Still there. Okay. So I'm not going to run gunzip on this one. So now I'm just running from base 64, right? From base 64, we get a whole bunch of additional stuff. I'm going to stop here, but guess what? I got an IP address at the end. And that's going to match the IP address that you guys found in the log files. And that IP address in the log files looks like it's the attacker's IP address. And so it looks like this PowerShell command that was trying to be run on your machine matches the log files that we have in the audit log file, right? For all the log4shell stuff, VMware. And that IP address matches this PowerShell. So I'm going to say this attacker is the same attacker that's trying to execute on PowerShell command in my machine over here. So that's pretty cool, right? Again, just know that you guys are drinking from a fire hose here, right? We're doing digital forensics really fast, And this is a lot of information that comes to you over time. You're not going to get super good at this, immediately, right? And so this is just a brief introduction to CyberChef. So you guys know, go to CyberChef. If you guys are ever playing with stuff and data and you want to decipher things or you want to code things or whatever, this is an easy tool to use that's available to you. Just know that other people also use CyberChef. So if you think you're really clever at encoding something, there's people that are also probably more clever than you at trying to decode what you encoded, right? So, but anyway, it's a great tool that's going to be, it should be on the back of your pocket if you're doing digital forensics, okay? All right, so we're done with that. We already saw that the backdoor execution wasn't successful because there was no file that we found in the home directory for the administrator. So the last question in this particular lab says, what other relevant events happened in the system? Okay, so I'm going to go back to our system here. One of the areas that a digital forensics person is always going to look at is the cache for the system. Okay, and one of the places where you look for cache events, okay, is going to be your AM cache. This is where applications execute on your system and they leave things behind, right, on the cache. And again, you would know this if you were doing digital forensics. You would know that in the Windows system, AM cache is one of the places where you look for things. Okay, so in the AM cache, I'm going to look at this. I would have looked through everything, but I'm going to pick this legacy entries because it's got the most and it probably subsumes all the other ones. So I'm just going to pick on that one, the legacy, and here's a whole bunch of entries. Okay, you can see that this is pretty big, right? There's a ton of stuff in here. If you were to look in Google for log4j and domains that are using log4j as a platform to do attacks, you would find out that one of those domains is called, and one of those executables is called consari.exe. You would just know that. And so because this is log4j, I would have this on my cheat sheet and I would say, is there a consari in here? So I'm going to sort this column, okay? And I'm going to look for that consari executable. This is ransomware. Consari executable is ransomware. So I'm going to go and look in here, okay? And let's see if I find I'm going to scroll all the way down. Go see if you can find that consari. Okay.
But I go ahead and check the UTF-16. So
Okay.
Instead of doing remove null bytes, we go decode text with UTF-16 element.
Perfect. Thank you. Let's see. There we go. There's a consari.executable. Okay. So we found a consari.executable. This is a known executable file that's known ransomware that attacks the system. Again, you know that if you were doing this type of search. So when we found that, we're going to look in here in the cache, see if there's any additional information for this particular file, right? And here you see that you get an actual hash. You get the hash of the executable. So this software is going to give you the hash of a lot of these files. It calculates the hash for you. So do I want to know what this is all about? So I'm going to take that hash. Okay, I already had it loaded here. I'm going to take that hash and I'm going to go to buyer's total. Buyer's total is a tool that allows you to search by hash number for a particular find that you find. That hash that you put at the very top, sometimes buyer's total changes it to be a hash that it's indexed that particular file by. So don't be surprised if it changes the hash a little bit because it's using the index version. And then what you find here is you start looking down and you're going to see all the security vendors analysis. So there's all these different companies, right, that have looked at that particular hash that you found on that disk, that you're looking at that digital evidence. And look at this. Trojan, I'm sorry, ransomware, ransom, everybody, all of these companies that are looking at this are basically telling you that this is some kind of ransomware, right? So what we've done in this lab, right, one of the first things that you do, you look at the description, you find information about the host, the IP address, the time zones, because you're trying to timeline the system. You look at all that type of information. Then you start doing a little bit of the malware investigation part. And Log4j was the one that was given to us. Hey, the system was attacked by Log4j. And so you already know a little bit about Log4j. You look at the applications that are installed in the system. We found out that vCenter or VMware was installed, and we know that it's a known target. So of course, I'm going to go and investigate the log files for those. I found a whole bunch of information from the log files. I found the timeline when the logins were successful. And so I have a timeline. I'm building my case. So now I have a really good case, right? Then I also know that as a digital forensics investigator, the two places I'm going to look for is auto runs. So as you found out, I'm going to see if anybody tried to install any auto runs. And I'm also going to look at the PowerShell history, because PowerShell history is where people are doing commands, trying to execute commands. We found one command that had a hidden flag. Of course, we took that string. We use CyberChef as one of the tools that helps us analyze that a little bit. And then we found out that there's also another piece of malware called kanzari.exe that attacks a lot of the systems. You would have a list of executables as a forensics investigator that you would search for. So in our case, we just searched for one that we knew about. We found the hash. We go to buyer's total website, and we find out that yeah, there's a whole bunch of malware that a lot of companies are saying don't execute that particular one. Okay, so now you have all of this information. Now you need to put the report together. And that's the report that gets given back to your client that just paid you $100,000 to do this investigation for them, right? And this is all the information that I have. And then that investigator can take this to a court or do whatever they want. Question?
I'm not sure if it was mentioned, but like based on the IP address, it would have been, the attack would have come from device in the local area network
because of the 192.168. That's correct. Yeah. You're correct. And I didn't want to go into that because, it's just hard to talk about IP addresses and subnetting and all this kind of stuff in the context of, but you're absolutely right. So, okay, let's take another 10 minutes and then we'll come back and do, yeah. Is this going okay for you guys? All right? Yeah, okay, excellent. All right, thanks guys.